Now in this question we are given two planes P1 and P2. Now it says which of the following straight line can be an edge of some tetrahedron whose two faces lie on P1 and P2. Now if we look at this tetrahedron, we already have two faces of this tetrahedron. This is plane P1 and then we have this other plane P2. Now this edge, it could be either of these three edges, in which case this line, it must lie on either P1 or P2. So first condition is line must lie on either P1 or P2 or both. And second, line is from one of these edges. Again, if it is this edge, it will line P1. For this edge, it will line P2, or it will intersect both P1 and P2. So it should intersect both P1 and P2. Now, if we look at this first line, we'll take a point in terms of lambda. So this point, it will be 1, 1, and then 1 plus 5 lambda. Now we'll see if this line intersects both the plane. Now if we put these coordinates in this first equation, we get 10 plus 15 plus 12 plus 60 lambda minus 60 equals 0. So it will be this 60 lambda equals 23. Value of lambda is 2360. So this point, it will be 1, 1 and it will be 175 by 60 on this plane P1. Now we'll check intersection of this line with the second plane. So for which we'll put x as 1. So it will be this minus 2 plus 5 plus 4 plus 20 lambda minus 20 equals 0. So here we get 20 lambda and it will be equal to 22 minus 9, which is 13. So here the value of lambda is 13 by 20, and this point, it will be 1, 1, comma, and this is 85 by 20, which are two distinct points. That means this A, it can be this edge of tetrahedron. Now what about second one? Again, we'll choose this in terms of lambda. Now here we'll get this as 6 minus 5 lambda, 2 lambda and 3 lambda. Now for this plane one, it will be 60 minus 50 lambda plus 30 lambda, 36 lambda minus 60 equals 0. So we'll get value of lambda is 0, and for the second plane it will be minus 12 plus 10 lambda plus 10 lambda plus 12 lambda minus 20 equals 0. So it will be lambda equals 1. So on this plane 1, this point is 6, 0, 0, and on this plane 2, it is 1, 2 or 3. So this second line also, it can be this edge of tetrahedron. Now we'll come to C and D. Now for both these lines, point is 0, 4, 0, and if we put 0, 4, 0 in this first equation, we'll get 0 plus 60 plus 0 minus 60 equals 0, and for the second equation we'll get 0 plus 20 plus 0 minus 20 equals to 0. That means this point, it lies on both the planes. So basically this line, it has a point which lie on line of intersection of both P1 and P2. Now in this case, it can be edge if and only if it will either lie in P1 or it lies in P2. That means dot product of direction ratios of this line and either of the two planes, it must be 0. Now direction ratios of the two planes, they are 10, 15 and 12, and here they are -2, 5 and 4. Now for this line, it is actually perpendicular to this second plane, so it doesn't lie in the second plane. And also for this first, if we check a1 a2 plus b1 b2 plus c1 c2, it will be -20 plus 75 plus 48. It is also unequal to 0. So this line, it doesn't lie in any of the two planes. That means it cannot be an edge. Now what about this third one? 1, -2 and 3. Now we take this dot product with the second plane, we get -2, -10 plus 12, and it is equal to 0. That means this line, it lies in this second plane. So A, B and D, they can be edges of this tetrahedron.